The last section that we need to complete actually comes from the appendix of this chapter, and I would be a little bit remiss if we didn't do it because this is exactly where you would go ahead and start off in intermediate microeconomics. So for the 2 or 3 of you that are majoring economics, this is exactly for you guys. And what we want to do is go ahead and take our utility maximization problem and see if there's going to be a graphical way in order to represent that. And there is, of course, going to be a way to do that. So remember when we did our utility maximization problem, find the optimum consumption bundle, we did so with very specific numbers and very specific methodologies. Here, we want to go ahead and see what the graphical way to represent that is going to be. And to start off, you notice here we have a green downward sloping line, which is denoted as I0 right here. And I0 is going to represent something known as our indifference curve. So let's go ahead and write down a few things for this. So the indifference curve. And the indifference curve basically tells us that everywhere along this line, they're going to give us a combination of both of these goods, which gives us the same amount of utility. So a curve that shows combinations, of goods from which, for which the consumer is indifferent. The consumer is indifferent. And in economics, the words indifferent just tells us that you're going to receive the same amount of utility. So you receive the same amount of utility. So everywhere along this line is going to give you the same amount of utility, even though the combination of goods may be a little bit different. So we just attach a sort of arbitrary utility number, as we normally do, and say everywhere along this I0 curve right here is going to give us, say, 50 units of utility. So point A, point B, point C, point D, it doesn't really matter. They all give us the same amount of utility equal to 50 units of satisfaction. At point A, we have 1 pizza and 2.5 hours of wall climbing. At point B, we have 2 pizzas and 1.5 hours of wall climbing. And C and D, you can do the same sort of things. But anywhere on this green line will give us exactly that 50 units of utility. And the indifference curve, as you can see right here, shares many of the same properties as our PPF. So why would something like point E be considered not preferred to something like anywhere on the indifference curve, say maybe C, D, B, or A? So something on the inside or to the left of this indifference curve are all considered to be not preferred bundles, essentially because you get more utility, you have more of one of these goods in any of these instances. So in economics, the more of a good you have, the more utility you are going to derive from it. So at point E, you have 2 pizzas and half an hour of wall climbing. But at point D, you notice that, yes, you have the same amount of hours of wall climbing, but you have more pizzas. Because you have more pizzas and the same amount of wall climbing, combination D right here has to give you more utility. Same thing in terms of B. At point B, you have the same amount of pizza, but more hours of wall climbing, so you have more of one of these goods, so therefore combination B has to give you more utility. So anywhere to the left of this indifference curve, these are combinations of goods that are going to give you less utility and therefore are considered not preferred. Something like F, on the other hand, is going to be considered a preferred combination because you have more of at least one of these goods. So anywhere to the right or away from the indifference curve that we have right here are preferred bundles, and they will give you more utility. So things to be aware about this indifference curve. And there are 3 properties of indifference curves that we just want to hit on a little bit more in order to see what the entire maximization problem is going to look like. So here, take a look at these 2 properties first. So properties of indifference curves. Difference curves. So property number 1 of indifference curves, at least the way that we sort of draw them here, number 1, they're always going to have a negative slope. Negative slope. So here, it's always going to be a downward sloping line. In higher level econ classes, this doesn't always have to be the case, and we get into really unusual cases. But in the way that we build this up in the principles class, our indifference curve is always going to be downward sloping. Number 2 property that we see is it's always going to be bowing inward. So it's convex to the origin. So convex to the origin. And when we say convex, it means the hump goes towards the origin. It bows inwards. Bows inwards. And once again, in higher level econ classes, this isn't going to necessarily be the case, but as we build it up in this principles class, we will assume this to be true. The third property of an indifference curve we need to introduce a little bit more for this. So in terms of just one indifference curve on this Cartesian plane, we don't just have to have this one individual indifference curve. In fact, there's an infinite amount of these indifference curves from the origin all the way out to whatever we want to sort of imagine it to. And each of these indifference curves is going to represent a different level of utility. So here, when we draw, say, maybe 2 or 3 indifference curves on the same Cartesian plane as such right here, we get something known as an indifference map. So here, take a look at this indifference map and what it means for us. The indifference map. And the indifference map is just an infinite amount of these indifference curves all plotted on one Cartesian plane. So an infinite set of indifference curves, an infinite set of indifference curves in which each curve represents a different level of utility. Represents a different level of utility. So here, the indifference map is just saying that we have more than one indifference curve, and there are an infinite number of them, but typically we'll draw 2 or 3 of them just for simplicity's sake. So with what we have in mind about these indifference curves, we have an indifference map. We have I1, I0, and I2. So out of all these indifference curves, which one of these indifference curves is going to give us the highest amount of utility? It's going to be I1 because it's the furthest indifference curve away from the origin. So we can say that this indifference curve gives us a utility of say 100. I0 is going to give us an indifference sort of a utility level of 50, and I2 is going to give us a utility level of say 25. So here we want to be on the highest indifference curve that we can because that gives us the highest amount of utility. And the same properties of the indifference curve still hold. So suppose that you were given a choice between point A, point B, and then point C. Which one would you choose? Would it be A, B, or C? In this case, it would either be C or B because it gives you the highest amount of utility. I0 is further away from the origin than I2 is. And because B and C, remember that it's on the same exact indifference curve, so they will give you the same amount of utility. So as we can see right here, each of these indifference curves, when we combine them all together onto one Cartesian plane, it gives us an indifference map. And the third property of an indifference curve comes from this indifference map itself. You notice that these indifference curves are never going to intersect with one another. They're always going to be parallel close to one another. So anytime we want to shift or take a look at a new indifference curve, it's always going to be another parallel line away from it. So the final property that we need to go ahead and take a look at is that these indifference curves, property number 3, cannot intersect with one another. So these indifference curves cannot intersect with one another. Cannot intersect with one another. And the reason why it cannot intersect with one another is if they did, it would create a logical impossibility. Creates a logical impossibility. So let's go ahead and see an example where these indifference curves intersect with one another and see why that's going to be creating a problem for us. So suppose that we have indifference curve I0 right here, and that gives us a utility level of say 25, just using arbitrary numbers. And we have another utility curve as such, I1 let's call it, which gives us a utility level of say equal to 20 here. And we have 3 particular points. We have point A, we have point B where they intersect, and then we have point C. And this is going to create a problem for us because these indifference curves are intersecting with one another. So when we compare these points, these bundles of goods, point A is going to give us the same exact utility as point B because they are on the same exact indifference curve. So A gives us a utility level of 25. B is also on I0, so it also gives us 25 units of satisfaction. Along the same lines, point B and C are also equal together. B and C are also equal together because they are also on the same indifference curve, each of them giving us 20 units of satisfaction or happiness. However, the transitivity property that we see right here should be holding, but it does not. So A does not equal to C. So bundle A gives us a utility level of 25, but bundle C gives us a utility level equal to 20. So therefore, the transitivity property that we see right here is completely destroyed, and therefore, this is the main reason why these indifference curves cannot intersect with one another. So any type of indifference curves, any indifference map that we take a look at, they're always going to be parallel lines away from one another. So these are the three properties of these indifference curves. They cannot cross, they have a negative slope, and they are convex to the origin. And based on what we set up right here, we can build up the idea of the utility maximization problem by including our budget line. So here, when we add in our budget line into our indifference map right here, we're going to be able to see what the optimum consumption bundle is going to be for us, and we're going to notice that it's going to bring us the same exact bundle of goods as we did when we had very specific numbers. So it's going to be 2 pizzas and 1.5 hours of wall climbing when we had $50 worth of income. And we'll see exactly how we come to that conclusion and see how a few changes can change that optimum in the next and final video.